Greetings and welcome to lesson 2.6 in your Big Ideas, page 78, where we are going to continue with our transformations unit. Ladies and gentlemen, we're going to continue not only with transformations, but we're going to add on to what we did yesterday with similar figures, where we are going to use these similar figures and we're going to apply what we learned today. These stated relationships, we're going to use them to solve some problems, and they're going to deal with similar figures. Our essential question: how do changes in dimensions of similar figures affect the perimeters and the areas of the figures? So, ladies and gentlemen, you were asked to, and I know you did, because that's the kind of person you are. That's the character that you have. You read the top of page 78, and you wrote down some notes on perimeters of similar figures. Now, stick with me. This is going to be a shorter video, and you're probably going to go like, yeah, well, what will we use this for? Well, you're going to find out in video 2, which unfortunately will be a tiny bit longer. So, perimeter of similar figures says when two figures are similar, that means the ratio of the perimeters is equal to the ratio of the corresponding side lengths. So here we have triangle ABC. We've got the perimeter of that triangle, the distance all the way around it. And then we have triangle DEF. And we have the perimeter of the distance all the way around that. So if I write that as a ratio, the perimeter of one to the perimeter of the other, that's a ratio. We're saying that that is equal to the ratio of the corresponding side lengths. In other words, right here, the ratio of AB to DE. Those are corresponding side lengths. Or the ratio of BC to EF. And also the ratio of AC to DF. All those ratios are equal. Now notice, when you have more than one ratio that is equal to another one, we have a massive proportion in here. Put that in the back of your head, because we're probably going to be using that later. But right now, we are going to talk about writing these ratios of perimeters for similar figures. So let's do that right now. Find the ratios of the perimeters. So it says find the ratio of red to blue of the perimeters of similar figures. So we're going to go red to blue. So I'm going to go like this. You might want to write on yours red and blue because yours come out in black and white. Or if you have color, you can color it in. It's awesome. So when we go from one thing to the other, whatever we start with, that always goes on top of our ratio. So if I'm going to write my ratio, if I'm going red, 21, that side length goes on top, and the corresponding side length to 21 is 15, and that's where we're ending up, so that one goes on the bottom. Now, ladies and gentlemen, you recall that ratios are similar, no pun intended. They are similar to fractions, which means one of the things we can do with these is we can simplify. So I look at this 21 over 15. Can we simplify this ratio? Yes, the answer is yes. I can divide both by 3, and I would get a resulting answer of 7 over 5. And that is the ratio of the perimeters of these figures. Nice. And yes, we will use that ratio later. Right now, we're just learning how to write them. Our second example, find the ratio of the non-shaded to the shaded of the perimeters of the similar figures. So again, I'm going to draw my arrow. I'm going from the non-shaded to the shaded. So I'm going to start here with the non-shaded. I'm going to make that red. The non-shaded is red. It is where we're starting. It is what goes on top. And I'm going to make the larger one, the corresponding side is blue. So I'm going to write 8 on the bottom. And then I take a look at this ratio, 3 over 8. Can I simplify this one? And the answer is no. So my ratio of the perimeters of these similar figures is 3 to 8 when I take the smaller one, the non-shaded, and go to the larger one that is shaded. Could I reverse it? I could reverse it, and that means it would just be the other way. 8 over 3 if I went from the larger to the smaller. Okay? Nice. Well, that's it. That's it for this first video. So your first quick write is to write the ratio of the similar figures for the perimeters, and I want you to do it both ways. A is small to large, and then B is large to small. So you're going to have 4 answers for these quick writes, A and B for each one, small to large, large to small. Ladies and gentlemen, when you're done, take a quick break, get a snack, talk to your mama, tell her what you talked about, and then come back and see me for video number 2.